I'm Dr. Ranga, co-coordinator for this Hackathon Online Therapy. I would like to welcome you all to this program, and I look forward to seeing you. And I look forward to seeing you all over the next 6 days, and I look forward to seeing you uh, all over the next 6 days.
Stream ಆಗುತ್ತೆ ಸರ್ 4 to 8 9 8 4 from 6. ஸ்ட்ரீமிங் யூடியூப்ல வரும் சார், ஃபோனில் செக் பண்ணி பாருங்க. லிங்க் அப்படியே ஷேர் பண்ணி விட்டுருவாரு. வீடியோ ஆஃப் பண்ணிட்டு பேசுங்க சார். சரி, ஓகே ஓகே. மேம் ஸ்டார்ட் பண்ண சொல்லிட்டாரு மேம் சார். ஓகே மேம்.
Good evening, everyone. It's my great pleasure to welcome you all to the AICTE Adult 6-Day Faculty Development Program on DevOps for Cloud Native Development, Containers, Kubernetes, and CI/CD pipelines. We are honored to have such a gathering of our esteemed faculty members, experts, and participants who are eager to explore the latest advancements in DevOps and cloud native technologies. This event is a wonderful opportunity to engage in knowledge sharing and skill building that will surely contribute to the growth of our academic and professional community. To formally commence the session, I now invite our esteemed coordinator, Dr. N. Balaji sir, to deliver the welcome address and extend his warm greetings to our distinguished guests and participants.
Good evening to one all present here. Our respected chairman sir, managing director ma'am, our respected CEO ma'am, our respected principal sir, Dr. Pradeep Devane, our vice principal Dr. K.B. Jayaraman sir, respected HODs, and the respected research and development head Dr. G. Amudoli ma'am, our office corporate relations Mr. Anandra sir, respected faculty members and respected research scholars and IT professionals, I welcome you all to the Atal Faculty Development Program on DevOps for Cloud Native Development, Containers, Kubernetes, and the CI/CD pipeline, organized by the Computer Science and Engineering Department of Sri Venkateshwaraa College of Engineering Technology. First of all, I would like to thank AICT for this opportunity. I am honored to be the coordinator of this program, and I would like to extend a warm welcome to all our participants and resource persons. All our resource persons are well equipped with knowledge to share their views on the DevOps for cloud native development, containers, Kubernetes, and the CI/CD pipeline, including continuous integration, continuous deployment, containerization topics. They have been carefully selected for their expertise and experience in the field, and I'm sure that you will all benefit greatly from their insights and perspectives. Throughout this program, we will be covering a range of topics related DevOps for cloud native development, including continuous integration, continuous deployment, containerization, and more, and with a hands-on training also. So we will also have interactive sessions, group discussions, and hands-on exercises to help you to gain practical experience and the knowledge. Once again, I thank you to all.
Thank you, sir, for your warm and gracious welcome. Your words have set the perfect tone for today's session. Moving forward, I take immense pride in inviting our respected principal, Dr. Pradeep Devanayan, sir, to address the gathering. His visionary leadership has been instrumental in driving our institution towards academic excellence. We look forward to hearing his valuable thoughts on the special occasion.
Good evening, ma'am. Am I audible?
Yeah, sir, audible.
Yeah, good evening, participants. It is a great pleasure for me to invite you all for this 6 days online FDP, which has been conducted by AICT Training and Learning Academy on DevOps for cloud native developments, containers, Kubernetes, and CI/CD pipelines. It's a great thing to see you people, nearly 120 people among here in this call, to be here, to be the part of this FDP, even in the after hours from 6 p.m. to 9 p.m. on the daily basis. This shows a great point of learning, so that every faculty members in every other different institution who have joined today are very eager to learn about the newer technologies that is driving the whole industries today. Crucially, when we see about the way what we always see about the engineering educations nowadays, the people always say about there is a lot of gap between the industry need, what the industry actually need, and what we deliver in the college. So there is also another paradigm which says that the engineers who are passing out of every engineering colleges are not equipped so well that they are not being in a point of being a productive person directly to be recruited and to be placed on the projects. So this shows a great a difference in between what we teach in our college and what the industry actually expects. This is not the actual phenomena where we go to the other professional programs like medicine, dental, and other areas where every other professor or assistant professor or associate professor who are working in medical college or dental college or even any other professional platforms and other colleges, what they do is they will teach in the college, and during the college hours also they will be working with the hospital, and after in the evening time they will be practicing their profession. But I hope everyone will accept that we as an engineer, as being working in an engineering college, we basically have a master's degree, or else a lot of people nowadays are now been into the research, and they have completed their research and they have got their PhD also. But we are not being equipped to well that what actually the industry is expecting. So we are till now lacking behind, so that to my point, it is not the students who are not at the lane of what the industry expect. We as a faculty are not in the lane of what the industry is expecting. So these kind of FTP program, especially the Atal FTP program nowadays, the AIST is targeting towards incorporating the cutting edge technologies into the faculty people so that they curate and they carefully select each and every other FDPs that has been applied to them. And that way, I want to congratulate our team, Dr. N. Balaji, HOD and Dean of Academics of our institution as a coordinator, and Dr. Andal ma'am, who is a co-coordinator, Associate Professor of CSE Department, to curate this topic of DevOps for cloud native developments, which is really needed by every industry, IT industry nowadays. So thankfully, we have a lot of resource persons who has been aligned in the pipeline. And today we have Dr. N. Sivakumar, Professor from CSE Department of Puducherry Technological University, and Dr. S. Senthil Kumar, Assistant Professor from the Department of CSE from Anna University, Trichy, who will be throwing the limelight on the basics of DevOps for cloud native development today. And I hope so that all these 6 days, every other participants will have a lot of learning for you, and hopefully will be having a great days of learning in the evening time. And thankfully, again, I always thank every other participants who are taking up their time, their personal time for attending this online FDP. Once again, I thank you all, and I welcome everyone for this wonderful event. Thank you.
Thank you, sir. Your guidance continues to motivate us for strive for excellence in education and research. Moving forward, we are fortunate to have the strong leadership and unwavering support from our Vice Principal, sir, in every aspect of our institution's progress. Under his guidance, that we continue to excel and innovate. I now invite Dr. K.B. Jayaraman, sir, to share a few words with us.
Good evening, everyone. Can you hear me, ma?
Yes, sir, audible.
Yeah. First of all, I would like to express my sincere gratitude to our Chairman, Managing Director, Executive Director, as well as Chief Operating Officer and our Principal for having this particular Atal Academy 6 days online basic faculty development program, along with all the 130 participants. And I am extremely very much delighted to have my sincere wishes to the organizing team, Dr. N. Balaji, Dean Academics and the Professor, Head of Computer Science Department, and the Co-Coordinator, Dr. K. Andal, Associate Professor of CSE, and all the organizing committee members and HODs and the Research Development Cell Madam, as well as Placement Cell Head, and all the relevant participants. So, it is a important 6 days FDP, which takes care of the fundamental concepts of advantages as well as serverless architecture, which takes care of continuous integration as well as continuous delivery pipeline, which takes the managing serverless functions throughout the cloud native development. Without further delay, I am handing over the session to the organizing team. Thank you all and have a great evening, great learning evening. Thank you.
Thank you, sir. Your words have... Thank you, sir. Your support truly motivates us to push our boundaries and achieve greater heights. Now I request our esteemed co-coordinator, ma'am, Dr. K. Andal, to address the participants.
Madam, unmute your mic, madam.
Good evening, all. I am Dr. K. Andal, co-coordinator of this online FDP. I would like to welcome you all to this program, and I look forward to seeing you all over the next 6 days. If you have any questions or concern, please do not hesitate to reach out me or our team. As we begin this 6 days program, I would like to take a moment to outline the expectations and the criteria for eligibility of the certificates. So firstly, attendance is mandatory and participants are expected to attend all the sessions. Any participant with more than 80% will be eligibility of the certificate. So secondary, there will be a final assessment at the end of the program, which will test your understanding of the concept and topics covering during the program. The assessment will be in the form of quiz, and a participant must score at least 60% to be eligibility for the certificate. So thank you all.
Thank you, ma'am. With that, we now move forward with the technical sessions planned for the day. We are excited for the insightful discussions and hands-on learning experience ahead. Once again, I extend my heartfelt gratitude to all our distinguished guests, faculty members, and participants for being part of this wonderful event. Let's make this faculty development program a truly enriching and memorable experience. Now, I request Ms. Vinita ma'am to give introduction about our resource person, Dr. N. Shivakumar sir.
மீட்டிங்கில் தான் சார் இருக்காங்க. அலோலாம் பண்ணிட்டேன் சார், ஹோஸ்டாகவும் போட்டேன். சார் ஓப்பன் அன்மியூட்டில் தான் சார் இருக்கு. அவங்க இது பண்ணாதான் சார் இது பண்ண முடியும். பேசுகிறாங்க.
Am I audible, ma'am?
Yes, ma'am, now audible.
Good evening to all. It's an immense pleasure to welcoming you, Dr. N. Shivakumar sir. He is a distinguishable professor at Puducherry Technological University with over 20 years of experience in computer science engineering. He holds a PhD in the field, specializing in software testing methodologies for agent-based systems. His research spans software engineering, artificial intelligence, cybersecurity, and Internet of Things, with 30 journal papers and 28 conference papers. He has held leadership roles in including head in charge of the Department of Management Studies and Associate Dean for Inter-University Collaboration and IQSC. He has contributed to industry collaborations, including a consultancy for the government of Puducherry, and is an active keynote speaker and organizer of faculty development programs. I would like to hand over the session to you, sir. Kindly take over the session. Thank you.
Okay, thank you very much for the warm introduction. Am I audible?
Yeah, sir, audible, sir.
Yes, sir, audible.
Okay. So, first of all, I would like to congratulate the team of this organizing committee for organizing such a wonderful program. And organizing an FDP is not a simple thing. And that too, conducting online is much more difficult job. So I think they started off well, and probably they will complete this particular FDP in a very successful way. And I also thank them for giving me an opportunity to be a part of this particular program to give the first session to start with. So let me share my slides. Hope my slides are clear.
Yes, sir.
Okay. Just stop it. Okay, so as introduced, myself, Dr. Shivakumar. I'm working as professor in the Department of Computer Science and Engineering. I also head the MBA department. I also take in charge of IQSC as Associate Dean, Puducherry Technological University. So with that, I will go for the session. So the session for today, I'm going to give you the introduction of this DevOps and cloud native development. So two terms are completely different, and somehow or the other, they are going to work in a collaborative way. So that is what I conclude with how these two can be collaborated and for the effective development of software development, right? To basically, when it comes to this DevOps and any sort of software development, right? So this software development life cycle is going to play a very major role, right? So this is what the basic thing from which any sort of software development kickstarts with, right? So it starts with planning, it goes with analysis, design, implementation, testing, and finally maintenance. So probably everybody might have come across these phases, right? So this is what we call it as a software development life cycle phases. And when it comes to these life cycle phases is concerned, using these phases, there are so many software development process models have been evolved, right? To start with waterfall model, spiral model, prototyping model, incremental model, right? So there are so many other models also. If you look at all the models, the core phases or the stages getting involved in this particular models are going to be the basic software development lifecycle phases only. I mean, the analysis, design, implementation, testing, and maintenance. But the way in which they have been processed, probably that will be differ from a process model to process model, right? So waterfall model builds software development in a different perspective, and spiral model approach the same sort of problem in a different perspective, and probably prototype model will handle that in a different way. Incremental model go for some version control software process developments. So in that way, every process model has its own advantages and disadvantages, right? To get into DevOps, right? So this is what the agenda I planned for this particular session. I'm going to start with waterfall model. And what is the advantage and disadvantage of waterfall model? Why we go for agile model? So probably agile model is going to be the upgradation of the basic software development process model, say waterfall model. And agile model, of course, it has some advantages, obviously, but still there are going to be some sort of, because every aspects of process development or any sort of concepts, obviously it will have some advantages, and at the same time there might be few disadvantages also, right? So agile model also have some sort of disadvantages. So probably that disadvantage when it comes to agile model is going to be overcome by the use of DevOps. So that is how the evolution of DevOps get into picture, right? And once we discuss in detail about what DevOps, what are the process model what are the phases getting involved in the DevOps, and what are the tools they are going to be made use in this particular DevOps, right? So that is how the stages of my lecture is going to be. And finally, I conclude with what are the advantages of making use of DevOps, right? So once this has been over, I will talk few things about cloud native development also, right? So once I complete that, probably I will link how this DevOps are going to be integrated as a cloud native development, right? So how this as DevOps is going to be applied as a software product development in cloud native environment, right? So that is how I'm going to conclude this particular session. Okay. To start with, basically everybody knows like the waterfall model starts with the requirement analysis. So basically, client come out with some sort of requirements, right? So assume a cost price shop owner or like a medical shop owners, they want to build their own like software for their billing and report generation. So probably they have to completely give their requirements to the like company, right? So that is what the first phase. So probably these clients, I mean the like these owners, they might not explain their requirements in a technical terminology because they don't know. They normally convey all those requirements in their own layman terminology, but of course these programmers will receive it and convert that particular terminology into technical terminology. So that is how it goes. So probably this like people, programmers accept the client requirements and they will start analyze, right? Analyzing in the sense whether this particular project can be done, meaning feasibility study they will come across. When it comes to feasibility study is concerned, so obviously they will check the feasibility of cost. That is very important. Cost feasibility, time feasibility, resource feasibility, all those things are going to be ensured, right? So that is what this particular first stage is all about, right? So requirement analysis phase. Once the requirement analysis phase has been over, right, they will jump into design. So basically, once the requirement analysis is over, the outcome of requirement analysis is going to be SRS document, right? That is software requirement specification document. Once the analysis team completes their job, they will come out with a SRS document. Now, this SRS document will be given as input to the design team. Right now, what these design team are going to do is they are going to convert all the requirements, whatever they have been gathered, in a like design oriented like representation. Because probably the purpose of converting into design is the main important thing is the easy understanding. That is very important. And of course, when it comes to design is concerned, identifying of errors, that will be very easy when we convert your technical terminologies into a design part. So that also plays a very important role. Now, once the design is over, so obviously they will come out with the design document. The outcome of the analysis team is going to be SRS document. Now design team receives that. Design team, once they completed their design, they come out with the design document. Once the design document is also over, now probably the development process will kickstart, the actual implementation. When it comes to implementation is concerned, the programmers are going to play a very important role. The programmers knows what sort of programming language I can choose, right, for building this particular product. Because for any problem, I can choose any sort of programming languages, right? So for a particular problem, I can choose C, C++, Java, Python. There are so many programming languages which I can use for building a particular software. Now the question is, which will be very efficient? Which will be like less time consuming, right? So which will be more appropriate, right? So based upon so many factors, programmers decide which software, I mean the programming language they can choose, right? So programmers code the application as per the project plan and the design. Once the coding is been over, obviously that has to be tested. Testing not exactly starts in the testing phase, but that also been taken care in the development process also. Because once people develop their code, obviously they have to ensure whether their code is running fine or not. So obviously they will test it, right? And when it comes to testing, like probably you might have come across, like we have white box testing, black box testing and all. So basically white box testing talks about structural testing, and black box testing talks about functional testing. So when you give input, whether your system gives the appropriate output, that is what black box testing is all about. When it comes to white box testing is concerned, whether all the statements is being executed at least once, whether all the looping constraints are being successfully completed, right? Whether all the functionalities are being successfully evaluated, whether all the parts has been successfully covered in this particular software. So that and all will be covered in the white box testing phase. So probably when it comes to testing phase is concerned, the testers will test this particular code using black box testing, meaning they will give the input, meaning they will derive test cases, they will give the input, and they know what is the expected output, and they will wait for the actual output. When these two matches, probably they declare the test case is being passed. So similarly, obviously they will derive so many number of test cases, because as long as the number of test cases are going to be higher, probably the probability of software quality is going to be higher, right? So the effective testing is directly proportional to the effective software. That is how it goes. So testing will happen. So testing ensures the system that has been developed is error-free and meets the requirement. Now, once the testing is over, now your software is ready for the deployment, right? So it has to be deployed, and once deployed, there might be a need for maintenance also, right? Once the application is developed, delivered, the operation team maintains that particular application, meaning in future course of action, if there is any updates, probably they will update the particular software. If there is any sort of unexpected errors, probably they go correct it, right? So there are so many maintenance, corrective maintenance, preventive maintenance, adaptive maintenance. There are so many categories of maintenance people talk about. So this is how a waterfall model works with. Now, when it comes to the disadvantage of waterfall model, what happens is, just imagine, when it comes to waterfall model, one particular phase has to be complete. Then only the next phase will kickstart. Meaning analysis has to be over. Then only your design has to be get kickstarted. These things cannot be done parallelly. It should not be done parallelly. That is what waterfall model is all about. If that is going to be the case, just imagine once, right, the design is over and somehow the implementation is also on process. Now the client suddenly comes out with a new requirement, right? As a client is the one who pays for our software, pays us for the software development. So obviously we cannot say no for them. At the same time, this waterfall model doesn't support that. So any new requirement from the client will obviously restart the complete development cycle. So that is a greater disadvantage when it comes to waterfall model. And one more important thing is, once you develop some sort of code, just imagine if the client is unhappy with the product, again, the entire product cycle has to be restarted. So these are some sort of disadvantages, right? And next important thing is, and obviously, when there are lots of changes that is being exhibited in a particular software, right, the expected outcome might be in a different perspective also. That in turn might also make the client not happy with that particular product. So there are so many reasons for that. Now, this is how it happens. Once all these things have been happening, right, obviously the software development lifecycle process has to be restarted. So that is not a simple thing. That is a very, very tedious process, because you are supposed to start from the scratch. So that probably is a greater disadvantage when it comes to waterfall model is concerned, right? And next, one more thing is, as I told you, the requirements given by the owners, the clients, they don't know technical terminologies. Probably they will give in their own understandable terminology. If that is going to the case, sometimes you know what happened, the requirements might not be clear, right? If the requirements are not clear, the project cannot be kickstarted, and obviously it will be eventually delayed also. So in that case, the time taken for completing a project is going to be obviously it will be increased. So that is also one great disadvantage when it comes to waterfall model. Now, one more important thing is, when it comes to waterfall model, the client requirements, just imagine the person who gives his own requirements, right? Not necessarily he has to give all the requirements at once. Let's say this happens for us also, right? Say when we would like to build a particular house for us, right? We contact a contractor. We probably give our expectation, requirements, everything we might have given. But during the course of action, during the building process, probably I might come out with some different ideas also, but that might not be been covered in my initial requirement explanation. So probably I might suggest, so why can't we change the structure like this, or why can't I include one more compartment to this particular phase? I might get so many ideas. So obviously that has to be incorporated in that particular software. That is what this particular first point. Client requirements cannot be understood at once. It is very expensive to make changes during the end of the project because almost everything has been done, right? So at that stage, if you come out with some new requirements, obviously that will be difficult for us, right? And one more important thing is software has to be delivered faster, of course, with less resources also. It might be time, like human resources, it might be anything, right? So this is how the basic requirements that has been accepted by the client, the companies, right? And now, when it comes to come across so many disadvantages with respect to waterfall model, probably people come out with a new model. That is what we call it as an agile model, right? So what they do is, when it comes to agile model, programmers create some prototypes to understand the client requirements. So it is going to do something like in a parallel way, right? Say client sends his requirement to the programmer, and programmer creates a prototype of that particular application very immediately. Creating prototype might not take much time, right? Now, prototype, as we all know, it is going to be a small working model. Now, let me demonstrate that particular small working model, that is a prototype, to the client, right? So that is how it happens. Now, looking into that particular prototype, obviously client might have some sort of feedback on that, right? So the client now provides feedback, and he will also give some list of changes that has to be exhibited in that particular prototype, right? So that is how it goes. Now, this particular cycle, right, meaning first thing I have to plan, and then I'll be coding it, right? Immediately I will test it and I review it. So this will be a small life cycle that happens. Similarly, this might happen for every single module, right? I need not consider all the modules together at a stretch. I can even go one by one, but I can do it in a parallel way also. So that is an important factor when it comes to agile model is concerned, right? So point is, the entire process of building a software is broken down into small actionable blocks called sprints. So every individual a cycle, we call it as a sprint, right? So when you talk to industry people, they will tell us every day there will be some sort of sprint meeting, right? Every day they will come across meetings with respect to this sprint, they call it as, right? So every individual cycle, small actionable block, we call it as a sprint. So this is what the actual working model or the workflow of agile model. So probably I would like to develop a product, and I would like to know what are the requirements for the particular product from the product backlog. Now I'm supposed to plan my sprint, right? So meaning I have to segment my product into small micro models, micro functionalities, and each this functionalities are supposed to be built using this sprint. So I have to plan for that, right? Now, as I told you, sprint involves plan, code, test, review. All these things will happen. And now one particular module is being ready. So now that becomes a deliverable product, meaning the customers can start use this particular product. They need not wait for the complete product. They can kickstart with one module that has been working enough that accomplishes some task, right? In that way, that particular product, deliverable product has been ready, and that particular product will be reviewed, because before review, I cannot make that particular product live. So I will review that particular product. Once it has been successful, probably I will deploy that particular product. So this is how the basic agile model works, right? Then when it comes to agile model advantages, the first and the foremost is going to be client requirements are better understood because of the constant feedback. Because I have a very frequent interaction with my client. When get some requirement from the client. I'm preparing my right, my prototype to my prototype, and now he matches his requirement to this particular prototype. If the prototype involves any sort of feedback, any changes, that is going to reflect or secrete and constant interaction among these two, right? So that is the greatest advantage. And next thing is, product is delivered much faster as compared to the waterfall model, obviously, right? So because like then and there, corrections like change and testing, everything has been happening very parallelly and then and there. So this helps for faster delivery of a particular product. Okay. Now I told you everything has advantages and disadvantages. Agile model also have its disadvantages. At the initial stage, people claim that Agile is the best software development process model, but it also has some sort of disadvantages. Start with the product gets tested only on developer computer and not the production system. Like meaning, like, when it comes to production system, where actually the software development product is being evolved, that is not happening, right? They are developing only in their like a developer system where it has been deployed. That part has been getting missed out. And one more is the developer and the operations, the actual people who are deployment out. So that is a disadvantage when it comes to agile model is concerned. And now this is how the issue, right? There is going to be a proper communication between developer and operations, right? So developers submit the product to operation team for deployment. Now this operation team has to deploy their product in the production server. So now this is the issue, right? When the product fails in production server, where you deploy, there is a problem. The operation team are clueless, right? They don't know because developers are the one who develop, and they don't the production server and the developers, they don't have an interaction. Only the operation people are going to act as a middleman, and that's why the operation team are clueless and send product back to the development team, right? So this seems to be one small disadvantage when it comes to agile model is concerned. Now to overcome this, right, the evolution of DevOps get into picture. So probably DevOps is nothing but the combination of development team and the operation. Development and operation together is what we call it as DevOps. Yes. Any questions? Okay. So when it comes to DevOps is concerned, DevOps is an evolution, right? It's obviously an upgradation from agile model. And one more, since I gone through a slideshow, I might not be able to look into the messages properly when you send it. So properly when I complete a particular topic, I come back to messages or any sort of doubts. Okay. So when it comes to DevOps is concerned, so as I told you, it's development and operations again, right? So it is that whatever a disadvantage we faced in waterfall model, that has been corrected in the agile model. Whatever agile model has some sort of disadvantages, that is going to be covered in this DevOps. Okay. And as I told you, this agile, I told you in the last slide itself, agile address the gap between clients and the developers. That is being done by the thing. But when it comes to DevOps, right, that creates a connectivity between the development team and the operation team. Operation team is nothing but where the actual software, the product is being deployed and in operation, right? So that is where the end users or the actual customers who directly start using that particular software. Okay. Now, when it comes to development team, what they do is they will submit their application, meaning the product, to the operations team for implementation, meaning implementation in the sense deployment. Okay. Now, once that has been deployed, probably what happened, those operations people, they might come out with some sort of feedbacks because end users or the customers are the one who directly uses that particular product. when the end users start using the particular product, as end users are different in numbers, different in mentality, they might use a particular product in their own nature. So probably there is a possibility that some cases, even though the testing team completely tests the particular software, but when it's been in live, but when it has been used by the user, there might be some issues also, right? So that has been covered in DevOps. Now, as I told you, DevOps is a collaboration between development and operations team, which enables continuous delivery of applications and services to the end users. So ultimate thing is the end users are the one who uses the product, and in case they have some sort of feedbacks, that has to be reached directly without any delay to the development team. That is being done by this. Okay. And probably you might have come across, right? There are huge scope. This DevOps is one sort of now in Instagram and YouTube also. When you get into, there are so many courses, and they might come out with so many job opportunities also for DevOps. So they call it as a DevOps engineer, and they come out with some fancy salaries, and this is been a kind of domain. So just like we talk about machine learning, data science, data analytics, we are talking about so many trending technologies, right? The same way, when it comes to industries are concerned, this DevOps, that thing plays a very important role in the resume also. Like when people see you are a DevOps engineer, probably that is an added advantage. Okay. Now, when it comes to the benefits, now we know the purpose of DevOps, where exactly, how exactly it has been used and how it has been get benefited. Number one, when it comes to DevOps is concerned, continuous delivery of software, because I told you Agile itself gives you a proper delivery of software. Right now, in the deployment phase, in case the end user feels some sort of difficulties, I mean the operation team, in case any difficulty, that has been directly connected with the development team. That is what we have been talking about. So once these issues are going to be worked out properly and ended up in a realistic, a faster way, obviously the continuous delivery, there won't be any sort of delay in delivery of a particular software product, right? And one more important thing is, obviously there will be some good collaboration among team members, right? It might be an operations team or it might be a development team. Obviously they will have some sort of collaboration, and easy deployment is also possible because they have great collaboration and they know where it has to be deployed and who is going to be the end user, who is going to be the operation team. So probably deployment is going to be easy. And one more very important thing is, as deployment is easy, right, we are able to satisfy the operation team, that is the end user team. So probably I can incorporate many number of end users in my what we call it as a particular software, right? Meaning it can be scalable, right? When it comes to scalability is concerned, so probably everybody might somehow or the other used IRCTC website, the railway reservation system website for booking your tickets, right? Now when you log in right now, right, so obviously what happens is you will go with the flow, a free flowing of what stages, you can easily log in, you can browse for your train and you can book ticket. You won't find any sort of delay or hindrances in train ticket booking. But when you start your booking right at around 10 o'clock, obviously that will be a tatkal time, right? So 10 o'clock will be for third AC and 11 o'clock will be for a normal sleeper class. When you log in, when you try to log in at 11 o'clock, so what happens is probably you can't even get in, you can't even log in to that particular system. And meaning that particular website is not scalable, meaning it has some numbers with which it can cope up with, right? It cannot go beyond that particular numbers. If many number of people, right, get activated with that particular login, try to use that particular login, it gets stumbled, right? It cannot move further, right? Deadlock kind of situation might happen. Okay. But this might probably happen, like you might have visualized when you look into some results, some 10th result or 12th results. On that particular moment of time, people say that 10 o'clock results will be released. At 10 o'clock, when you try to log in, just imagine lakhs and lakhs and people will be trying to log in and visualize their marks. So probably it won't support. So meaning scalability, right? So there will be only 1,000 users can access this, only 10,000 users can access this. That might be the case. But when you make use of Google, right, probably worldwide Google website will be made use, and of course parallelly millions and millions of people will be making use of that particular Google. So probably when you use Google, you never ever felt that many number of people are right now active in this particular Google, right? So meaning it is such a compatible, such a adaptable, and it is completely greater scale, so that any number of users can access that particular website in a parallel way. Okay. And one more thing is, when it comes to error, right? So error identification, fixing of errors can be done at the initial stage itself. And one more, better security. That also a very important thing. And manual intervention, that is going to be very less, right? Because everything are going to be automated, and obviously there is going to be very, very less manual intervention among the developers and the operation teams. And next is the DevOps phases. So as we have some phases with respect to software development lifecycle, right? We have some important phases in DevOps also, right? The phase starts with plan, code, build, test, integrate, deploy, operate, and monitor. So there are going to be some 8 important phases, right? So this is what the workflow or the phases that gets involved in DevOps. Right now, we are going to look into each phases in depth. The first phase, as I told you, it is going to be a plan phase, right? So obviously in plan phase, what happens is the business owners and software development team discuss project goals and create a plan, right? Say, I want a particular software that has to be done. So obviously I'll come out with my own requirements that will be received by the software development team. Now they set some project goals. Based upon the project goals, they will create a plan. So probably the plan involves scheduling, functionalities, right? And how it is going to be all sort of initial level of planning. Every aspects will be carried over or done in this particular plan phase, right? Once the planning is over, right, immediately they start doing the code, right? So it is not just like software development, go for design, nothing. Once the plan is over, they go for coding. Now, programmers, right, then design and code the application and use tools like kits to store application code. So probably you might have come across something called GitHub, right? I will talk about that in the later stages. So now, when it comes to this code phase with respect to DevOps is concerned, GitHub is an excellent example, and that takes care of coding part, right? So when it comes to DevOps is concerned, right? So this is what the second phase that talks about coding. The third phase is, now I would like to build, right, some sort of code, right? Say, we have so many tools. This also I will talk in the later stage. We have something called Maven and Cradle, right? These, tools take code from different repositories and combine them to build the complete application. Now, there are some ready-made codes or a sort of modules, right? Some sort of packages, some plugins. So these sort of things I can ready-madely, there are some sort of repositories that will be available. I can even pick up them. Only botheration is going to be, I can consolidate them. I can integrate them so that becomes a product. So I have so many codes, and my next job is going to be integrating all these codes to come out with a one single product, right? So that has been taken care by the what we call it as Maven and Cradle software. Now, once you planned, right, and you started coding, and now you build a particular product. Now, right now, you are in the testing phase, right? So obviously, you have to test your application, right? So as I told you, testing, once testing is over, then only you go for debugging, right? So testing involves identifying errors. As much errors as you identify, your testing is going to be effective, and the quality of software is going to be effective. So you can take much time on the testing phase also, right? Now, when it comes to testing is concerned, we have a testing tool called Selenium. This is a very famous testing tool you might have come across. So this Selenium tool ensures the software quality, meaning if the software has been tested effectively, obviously the quality of the software is going to be good enough. Okay. Next thing is, once testing is over, right now, I would like to integrate, right? Meaning, just imagine you got you've been asked to build a website. Right now, you start building your website in your standalone system, your laptop, say for example. Now, in that particular laptop, you got your website ready, and probably will test, right, all the links, hyperlinks, and all the data that has been present in that particular website, right? So everything you try to test it. And for your kind information, you are testing in your laptop itself, right? Now, the point is, once you are satisfied with that particular website, every nook and corner, all the links has been working fine, and you tested it well. Now you are supposed to host this particular website in a web server, right? So next stage is it has to be hosted. Now what happens is, during hosting, right, or after hosting again, right? So you have to ensure whether after hosted, every hyperlinks, links, everything has been working fine or not, right? So that is what, once you come out with that particular code, you have to integrate your code with web server, right? The same way, you might go for some sort of networking software, right? You might go for a client server software. It might be anything of that kind. So once the testing is complete, right? Is there any new feature I can add up with? That has to be thought about. So new features are integrated automatically to the already existing code base, because that might add some value to the existing code, right? This new code probably maybe depends upon the competitiveness, or there might be some legal policies. The reason might be anything, but there is a probability of adding new features to the existing code, right? And once integration has been over, now you have to deploy it, meaning it has to make workable, right? So it has to be used by the end users, because we are developing a software for a purpose that has to be used by the clients. This has to be used by the end users, right? So if that is going to be the case, I go for deploying this particular thing. So application is packaged after release and deployed from development server to the production server. So that is what I'm talking about. So once it's been done, it has to be put inside the development server, the production server, meaning in the web server, if it is a web application, right? So that is how deployment happens. Once deployment is over, right? So now it has to be made operatable, right? So once software is deployed, operations team, right, perform activities such as configuring server and provisioning them with the required resources. Because holding or storing some content in web server doesn't solve our problem very immediately. That has to be configured in which port number your software is going to be working in, right? There are so many things that has been getting involved, right? whether all the plugins that has been required so that your software your web application that will run in a web server so that the entire world can view your website. In that way, I have to ensure whether all these things are operatable. So once the software is deployed, operations team perform activities such as configuring servers and provisioning them with the required resources. So that is what the next stage. Once the operation is also over, now everything is over. Like we cannot let it as it is, right? So we have to monitor it, right? So monitoring allows IT organizations to identify specific issues of specific releases and understand the impact of end users. Probably this happens for any products. It might be a physical product or it might be a software product. Say mobile phone, one that has been made ready, it is coming out to the market. Once a mobile phone is coming to the market, obviously it might have been tested, right? Without testing, no product will come to the market. Obviously, when it comes to this mobile phones and all, it is going to be very, very sensitive. Sometimes the brand of a particular a product will go off if the product doesn't works fine. The same thing happens for cars also, vehicles, car, right? You might have come across. We claim that this is a failure car. Sometimes the manufacturing company itself declare a particular vehicle as a failure vehicle, and they claim and they say that it can be given back so that you can get a different model vehicle, and that or some scenarios in real time a thing itself we might have come across, and that is being an effect with respect to monitoring. So when you closely monitoring your software, how it performs, whether end users are been using that particular software in an effective way, in a proper way, then obviously what happens is monitoring will come into picture. In case if there is any issue, obviously if it is a correctable issue, that issues can be corrected then and there. Even if not, sometimes it can be an extended detailed issue that might need some time, right? It has to be get back, and it has to be monitored well, and it has to be corrected, and it can be resent again to the operation team. So that is how the monitoring plays a very important role. So that is how your complete phases, 8 phases will plays a very important role. Now this slide gives you a clear idea about all the 8 phases, right? Plan, code, build, test, deploy, operate, monitor, and of course integration is a key thing, right? And for each and every phase when it comes to DevOps is concerned, right? We have so many tools getting involved, right? And this is what we call it as DevOps tools. This is what people are wanting for, meaning in the resume, what sort of DevOps tools you know, right? GitHub, when you like to go as a software engineering, for the students I'm telling, when they would like to go for an interview or they want to build their resume, this GitHub is very, very important. They want IT related companies, they want this particular GitHub to be known by the developers. And of course, the new joinee also, they are expecting to have this sort of, right? And as I told you, there are so many other tools that has been used, say for building a particular software, right? Maven and Cradle are being used. For testing, I told you, Selenium. And JUnit is a component. Even in Java, we might have come across this JUnit module, right? And when it comes to deployment, we have something called Docker, Chef, Puppet. These are some tools that has been made use for deployment, right? And when it comes to operations also, the same tool can be deployment and operations, or somehow or the other closely related to one another. These tools are readily supporting this deploy and operate. And when it comes to monitor, right, we have something called Splunk and Nagios, right? These tools are widely used for monitoring purpose. And for integration, I told you, all these software modules are supposed to be integrated. So when it comes to integration is concerned, these things, Jenkins, Bamboos, all those things are going to be made use. Right now, I'll talk about the individual tools so that you might have some sort of awareness of what are the tools. Maybe as a teacher, we should also come across these tools somehow or the other. And there are so many learning platforms. Like, to be frank, whatever I am talking right now, I took the content, right? So the ideas, the tool, whatever I'm showcasing, I took from a learning platform called Simply Learn. Probably you might have come across, right? So I register and I for myself I study some sort of what we call it as to be with the flow of the technology. So we are supposed to have some sort of ideas about what is happening in the industry, so that we have to teach our students so that they have to serve an IT company, right? So let me start with when it comes to plan and code, GitHub is a very important thing. You might have come across this particular thing. The purpose of GitHub is it is going to be an integrated development, right? Say for example, now normally how development happens is, probably you might have come across one particular software development or a software is not been developed by one single person, right? So team of members are going to be getting involved, right, in the software development. Also, when it comes to team is concerned, every software development life cycle phases will be performed by individual team. So meaning there will be some analysis team, there will be some design team, there will be some coding team, there will be some testing team, right? This is how it happens. And when it comes to the development team is concerned, they are the programmers. Those are the who build their code, right? Now, when it comes to development team is concerned, again there will be n number of people in that particular development team, right? And all those team members are going to build one particular module or one particular software, right? Just imagine, as long as, obviously when it comes to software is concerned, modularization is very, very important, right? So we will segment, the software into pieces, meaning separate modules, so that one module will be done by one team member, another module will be done by another team member. That is how it goes. Now, when it comes to module working, again the module in turn might have so many functionalities, right? And when it comes to functionalities is concerned, each functionality will be involving more number of lines of code, so that every individual functionality will be given to a particular team member, right? I repeat, one module will be given by 10 members, say for example. That particular module involves some 10 functionalities. Each member will be given each functionalities. Now, as long as there is no dependency, right, among the task, among the functionalities, among the modules, so obviously we can perform parallelly, right? If there is a dependency, obviously we have to wait until one particular task has been completed, because for certain cases the outcome of one module will be an input of another module. So if that is going to be the case, we have to wait for that particular module to be get completed, right? If that is going to be the scenario, just imagine, as I look into this particular slide, assume there are some 4 tasks, right? Now each people, like the team member, whom we call it as a developers, they will start doing their task, right? Just a minute. Okay. When it comes to the individuals who take care of these tasks, sometimes other programmer, right, might had to do something, right, on some other task, right? Assume if the particular modification of that particular code happen, right? And that in turn will affect one more programmer. Obviously, whatever the code he has been done might be completely changed. One small change, but completely collapse the complete module also. That also have some sort of chances. So meaning before like GitHub, right? The evolution of GitHub, the actual challenges is no collaboration, right? Where you store the code, you have to store the code in the server, right? And if you are storing that in the server, right? If anybody can access it, just imagine, right? We don't know who accessed it, who modified it, and in case the software turns in a bad state, nobody is going to take responsibility on that. Even if the person who changes the code, like it might not be purposefully, but still, right? Unknowingly, he do something for the benefit of that particular code, but went into a wrong state. He is not going to accept. Probably he's going to say no, that I have not touched your code, right? That is going to happen. So there's no collaboration among the team members. And one more important thing is versions are not maintained properly, right? So this also happens even for a Word document itself, right? When you're preparing PPT or when you're preparing your Word document, right? So this versioning plays a very important role, right? So you do some changes. Sometimes whatever changes you have incorporated, you have to undo it, right? So we create so many versions. So version 1, version 2, or based upon dates, we might save our Word document, meaning in case, right, something goes wrong with today's Word document, right, I can get the data from the yesterday's saved document, so that starting from the scratch, that might be got avoided, right? And when you do that, obviously it is going to be time consuming, right? And one more important thing is, in case, just imagine the server crashes, obviously there is no way to recover it, as there is no backup at all. So these are some sort of difficulties or challenges that has been exhibited, right, before the evolution of GitHub. Now, once GitHub has been evolved, has been created, has been in line, right, with the software developer, what this software developer do is they put all their tasks, whatever they do, in a GitHub, right? Now what happens? Anybody, these 4 programmers in the slide, they can access any task, right, at any time. What happens is they can upgrade the code, they can modify the code at the same time. Who updates it, who modify it, everything will be recorded, right? Who changes that. And one more important thing is, at what point of time, in the sense that probably the software will have n number of lines, right? You assume the code involves some 10,000 lines of code. You are doing some changes, right, at some around 2450. That line you are doing some changes. Now you changed it and you closed it, and you're getting back again next day. You yourself doesn't know what sort of changes you have done, at what level and at what stage, right? So these are the issues that has been solved by this GitHub. Now what happens is, as I told you, if you do any sort of changes, right, everything is being logged, everything is going to be recorded, right? Which user does the change, at what time does that the change, at what key area it has been done, which module it has been changed, which functionality that has been changed, what change that has been exhibited, everything can be done, right? Assume assume that the code that has been modified is my own code. If the changes exhibited by the other programmer is good enough, if I feel yes, this code is been rightly optimized, then I might leave. If the code that has been modified is not good enough, it has not been satisfied, I can even revert back. And once it has been revert back, that in turn will be also be reflected, right, or intimated to the others, right? So in that way, GitHub plays a very, very important role, meaning there will be some sort of team collaborations, and versions of software or documented and maintained accurately. This is what I'm talking about. All versionings, even if you change, right, the small change, that becomes a version. So that in case if you are reverting back that particular change, you can come with like older version of original code which has been unchanged. So that is what that GitHub has been very famous. And of course it saves time, because there is no your contribution is not going to be much on saving or versioning. Everything will be taken care by the GitHub, right? And also it is easy to use. Just imagine these sort of things that have been very complex, then obviously we will not go touch this particular GitHub. This is very user friendly and very easy for us to make use of it. And one more important thing, automatic backup has been integrated into this, so that in case any sort of failures, in case any sort of security breaches, I can even go back and take from the original, and I can proceed further with a different perspective. So that is how GitHub plays a very important role. So as a definition, GitHub or Git is a distributed version control tool which is used for managing the source code. That meaning, like whatever code you do, that is not going to be available in your laptop. Every code is going to be there in the Git, right? So that anybody can even your head team leader or project leader, they have to analyze what sort of code you have done, how much you have done, right? Have you completed your task as per the deadline? If they would like to ensure this, everything they can look into the GitHub itself. They need not get any detail from you. They know from the GitHub how much code you have done, how much has been left out, everything, right? So in that way, now every software development industry, right? Even nowadays, our students also, probably you might have come across, when they are doing their project, they started using this GitHub, right? And as I told you, it is a version control, distributed version control tool. And when it comes to this, to simply define it, it is a software tool, right? You can install it and you can make use of it, and it is readily available in the web. The website will be github.something.com, and you can visit and you can log in and you can start using that particular GitHub as a server, integrating many developers and task managers to incorporate their code into this particular thing, right? And it is used to track changes in the source code. I told you, if a person, if a user, if the client or if the developer, right, if the team member does some sort of changes, right, so it can't be it can't be unknown, right? Clearly, it will be tracked. As I told you, which person, which time, which place, which number of lines of code, everything will be recorded, right? And one more obvious advantage is going to be multiple users can work together, right? So in any number of users, it is not that only 5, 10, no. As long as the project is complex and great enough, right, that involves say 100 team members, yes, 100 team members can work in a coordinated way using GitHub, right? And this also support parallel development, right? So meaning non-linear. Linear means step by step, right? Once this has been over, once this module is over, I'll kickstart with next module. That is not the case here. It's supposed non-linear, meaning parallel development is very well possible using Git, right? So this is about your GitHub. Now, when it comes to plan and code, I introduced something about GitHub, right? Now, when it comes to building, right, the build phase, we have something called Maven. Now, building in the sense, just imagine there are many components involved in that, right? So when you make use of many components, right, that helps you to build a particular empire or the code I'm talking about, right? So Maven plays an important role when it comes to build, right? So let's see something about Maven. Now, when it comes to Maven, I come across a very simple example. I'd assume that you have a task of creating a football game using some technology, say Java, right? Just imagine football game is not a very simple game. that involves so many things. Just imagine how many players are getting involved, right? It is always mobile, right? Your football is going to be mobile. I mean, in movement, and the players are going to be in movement, right? And you might have seen so many audiences, right? And goalkeepers, and you might have come across the trainers, coach, right? Everybody will be the actors in that particular playground, right? Now I have to build a particular code, right? I have to incorporate all these actors, and all these actors has to work in a coordinated way, right? Then only this particular complete football game will look nice, and that can have a realistic experience, so that people will play with some interest, right? So that sort of thing is being done using Maven, right? So the disadvantage before Maven is, for each project, assume it is a football game, you need to keep adding a set of jars, meaning set of jars in the sense set of actors, right? It might be anybody. You might have seen some alternate people, right? So they might get into action, right? Say the team owners, they will be standing there. The what we call it as goalkeepers and team coach, audience, right? So many people getting involved. So step by step, I add to that particular environment. I cannot add everything together. First, I have to build that particular lawn, the playground, and then I have to set up the post, and then the stadium, and I start incorporating each players into that, and each players I have to map them to a country so that they wear the appropriate costume. Do you understand? So all these things I will do in a step by step things. So this is what we call it as setup jars, right? So that will be difficult, right? Before Maven, these sort of working is going to be very, very difficult. And even a minor mistake in the structure of servlet doesn't give the right output. And obviously, just imagine you do some small unintentional a mistake, right, in the entire jar integration, right? Obviously, that will go in a different way, right? And building and deploying a project takes us a lot of time, because it involves so many activities, right? So many actors, right? Each actor has to be doing their own job, and they have to reciprocate to the other actors, and that's why it takes lots of time. Now, when it comes to Maven is concerned, right? So what happens is Maven has a live templates in its central repository, meaning a ready-made actors, ready-made structure. I want a lawn. For that, the ready-made code will be there, right? You want to set up a goalpost, right? So you can do that very immediately. You need not go for so many difficulties, right, to setting up that sort of game, right? And a user has to declare only the dependencies that he requires. I told you, obviously, there will be some dependencies among the players, among the actors getting involved in that particular gaming, right? So that should also be understandable, right? Which user connects with what user, which user which player connects with what what we call it as goalkeeper, right? And there will be referee, and which player in connect with some exceptional scenarios, if the umpire is showing some sort of red card, obviously you show some aggression that has been showcased by that particular player. That and all has to be recorded, in the sense that and all have to be incorporated in that sort of. So that is what Maven does. Maven will download and deploy the dependencies with the application. Once you set, just like a linked list, right? When it comes to linked list, you create a bond among the first node and the second node, right? Once you create that particular bond, it is easily understood that this is the precedence, our predecessor, or this is the successor node. That and all, that understanding we can very well have. Okay. And as I told you, Maven is an automation tool which helps to build and manage software project within a short period of time, because ready-made actors, right, integration, plugins, you can have it, right? So as I told you, it supports parallel builds, easy to use, and instant access. That is very important. Instant access to new features with no additional configuration, right? And the building process is going to be easy, just like a drag and drop. Next thing is, once the Maven and the build process is over using Maven, right, we go for testing. For testing, we go for Selenium, right? So basically, Selenium is a very powerful tool for testing. So basically, when you go for testing, we'll be testing the modules or the test cases step by step, one after another, right? That is what we call it as a sequential testing. And of course, that involves lots of time, right? But when it comes to Selenium is concerned, parallel testing is possible. Right? Test cases can be like automated test cases. Nowadays, you probably might have come across. We have something called manual testing and automated testing. This Selenium comes under the automated test tool. They can do that in a very parallel way, so that the testing is going to be get completed at a faster rate. Okay. And one more is, as I told you, Selenium is a software testing automation tool, and it is open source, right? You can even download it, and this helps for effective testing the web applications, mainly for web applications, right? And one more important thing is, this is also can be used for regression and functional testing also, right? When it comes to regression testing is concerned, just imagine there is something called unit testing, meaning one module, one unit will be taken care by a particular person. He completes his own unit and he tests that particular unit. So that is what we call it as unit testing. Individually, assume that 10 units are being tested individually by the 10 programmers. Now all these 10 units has to be integrated, right? So individually the software, the modules are working fine. Now I'm supposed to integrate. When I go for integration, just like that, I cannot integrate. I might need to write new lines of code to connect this module and that module, right? So when I go for new lines of code, that new lines of code in turn should not create any sort of bad effect to the existing modules, right? I would like to test that. So that testing is what we call it as a regression testing. Okay. So Selenium supports faster execution and it comes with some high accuracy, and that's why it is very popular. And scripting is also possible, meaning automation, right? I can write my own script for testing a particular module, because that in turn gives me a new test cases, generating of test cases, test case prioritization I can do. So if that is going to be there, obviously fast execution might happen. And finally, it supports parallel test execution. As I told you, you need not be very sequential, one after another, right? Parallelly, the test execution can be supported by the Selenium tool, right? And once testing is over, right? So we have to go for integration, right? So for integration, particular a software called Jenkins, right? So that plays an important role for integration here. So what happens is, assume the developers are developing their code. Once they develop their code, they put their code in a repository, right? Now all those codes individually, whoever done it, that has to be integrated, right? Once integrated, that has to be tested, right? If there is no error, obviously that will be delivered. If there is error, which module has an error, that will be notified to the respective developer. So this is how the modules earlier it has been working enough, right? But what happens is, developers has to wait till the software was built for test result. Just imagine, I developed the software, now I submitted. Now I have to wait until the testing is over, because testing will give us feedback. Testing will give us test result. Test results might have some faults. Those faults I am supposed to rectify. So I have to wait for it, because before the results, I cannot go for the next module. Because if I go for the next module, if I get the results of the earlier module, probably that will create some sort of clumsiness with respect to the executions. Right? So that is a greater disadvantage. And one more important thing is lack of continuous feedback resulted in a lot time consumption. Just imagine there's no feedback. It's a delayed feedback, right? Whether it is right or wrong, unless or other than we get a at the earliest feedback, probably it might be corrected at the earliest. If not, it will be a tedious task, right? And just because of this, the software delivery, that is of course delayed. These are some issues, right, before this Jenkins get into picture. Now what happens? Jenkins allows building, testing, and deployment as a single integrated tool, right? So that I can get a faster remedy or faster feedback or faster test result from that particular module. So that will be notified to the particular developer at the faster rate, so that the developers need not wait a longer time for their test results, right? So that is what the effect of Jenkins. So Jenkins allows easy installation and configuration, and it has multiple plugins. Right? Meaning, this Jenkins involves integration. So obviously there will be multiple plugins that involves in the particular software, and that can be integrated, right? So that for an effective software. So that has been supported by this particular Jenkins, and this Jenkins can be extended via plugin, right? So that is one more important thing, and it is easily distributed across multiple machines because it is an integrated integration tool, right? It can be crossover, right? And it can be distributed across different machines also, right? So Jenkins is an open source continuous integration tool. It helps to automate continuous development, testing, and deployment of newly created tools. Again, there is some sort of integration that has been happening, right? Once the integration is over, right, we go for deploying and operations, right? Operate. For this, there is a tool called Docker, right? So this is a separate tool, right? Whatever tool that I'm talking about, everything or an extended version of content delivery is going to be there, right? So Docker is one important thing. So basically what Docker does is storage, right? Just imagine, normally when you go for machine usages, memories will be occupied. When you use your process, you might use different application. Each application process might utilize some memory, right? So that is one. Now when it comes to this unused memories, right? So that and all will be mere waste when it comes to virtual machine is concerned, right? So in this particular example, right, 10 GBs, right, has been utilized, and 6 GBs have been unutilized with respect to virtual machine. So obviously the 6 GB are going to be mere waste, right? So why should I do that? So we should also, because memory plays a very important role. Probably you might have come across when your systems, when your system performance go down. So immediately the immediate remedy, right? People suggest us increase the RAM. When you increase the RAM size, the capacity, the performance of your system might boost. Just because any application you load, right, you open in the particular operating system, that is going to be run, right, executed, right, via this particular RAM. So when you use so many Chrome tabs or internet tabs, and you use so many applications in parallel, sometimes you might get into a deadlock situation. So probably we'll go for Control-Alt-Delete and go to the task manager, and you kill some task because it is in the deadlock situation, right? You kill some task. I mean the end task you do. Once few task has been ended, probably other task might start working enough, right? So these and all are the damages when it comes to memory shortage is concerned. So that has been handled by this Docker, right? And that's why Docker is an OS, operating system level virtualization, because memory management is being done by operating system, right? So Docker is an OS level virtualization software platform that enables developers and IT administrators to create, deploy, and run applications in a Docker container with all their dependencies. Probably I see some lectures on Dockers and containers also. So probably that talks about in detail about this sort of phase. Okay. And as I told you, this is highly scalable, because memory utilization, I told you I can when it comes to virtual machines is concerned, I can increase the size of the memory whenever that has been needed, and short boot up uptime, right? When you boot, in the sense when you switch on your system, your operating system is on, it has to be booted, right? The desktop might come at the earlier time itself, right? That is what boot up uptime we call it as. And your data volumes can be reused, because all your data volumes is being utilized by the memory, so that can be reused. And you can have so many isolated applications also, because we can't rely on application that has to be stored in a sequentially in a memory, right? In the memory, your isolated applications might get stored randomly, right? So it supports isolated applications also, right? Once the deployment and operate is over, finally we are supposed to monitor, right? For monitoring, there is a software called Nagios. Oh, sorry, this is Ansible. Okay, so this is this is for operations, right? Earlier we discussed about deploy. For operations we use Ansible, right? Just imagine, now I would like to run my piece of code, right, in web servers. Assume I have many web servers, say 3 web servers I have and 2 database servers I have. Everything has to be run parallelly, right? So this will be a difficult situation. For that, this sort of Ansible, right, that is a software, right, that has been used, right? So for overcoming this sort of difficulty, so it supports, right, when you start using Ansible, a code is written once for the installation and deployed multiple times. Even you can install this particular software code. In this slide, I have given it as 33 web servers and 22 database servers. You can go for n number of web servers also, right? So that is the complement that this particular Ansible gives us, right? So it has it is a push-based configuration tool, meaning as long as, right, say new web server pops in, right, accordingly I have to manage that particular web server also. I cannot say no to that particular web server, right? And it is an agentless tool, it acts by its own, right, and maintains consistency of a product's performance. So just because many web servers has been accommodated, the performance cannot be compromised, right? So this maintains the consistency of the product performance, right? And they use some a secure socket thing with respect to the connection is establishment is concerned. So that also works fine with respect to Ansible, right? And finally, for monitoring, we go for Nagios, right? So now, just imagine when something goes wrong, right? Some service is not working fine, right? How do I know which service is not working fine and what might be the reason for that particular service? Because there might be so many reasons for a particular service getting failed, right? Now, there is a big question mark for the developer, right? Why my service is not working, right? So it might be different reasons, right? Now, assume this particular Nagios helps you to identify the reason why the service that has been get failed, right? If the reason is, right, your memory is almost full, if this is going to be the reason, that will be notified to the user, so that the user need not be panicked, and now he gets the point, what is issue. So accordingly, he might like fulfill this particular issue at the very easy rate itself, right? So that is the effect of Nagios. And as this is easy to use and high availability is going to be there, and like comprehensive monitoring. So like meaning continuous monitoring that is going to be there with respect to Nagios. So all these things, right, plays a very, very important role. So as I told you, when you take up this particular tools, right? So one by one, if you try to explore, right? I have shown you right now about Kid, Maven, Selenium, like Jenkins, Docker, Nagios, Ansible. So these are the tools I was talking about. So at each stage, right, we have to experience, right? We have to explore each technologies, each tools, so that the complete DevOps will be greater learning. Okay. And finally, to end up with, we have some development DevOps processes. The main important thing is continuous delivery. So this is what the key factor when we use the DevOps, right? So continuous delivery will be there, and continuous integration will also be there. Because you plan, code, build, test it. Probably when you release it, there might be some sort of issues, some sort of defect, failure. So that has to be integrated, that has to be identified. And again, it has to be monitored, operated, deployed. Everything is going to be a continuous process. So this is also an important process when it comes to DevOps. And now when you browse, now every company, starting from Google to Netflix, right? Every company started using DevOps. The main advantage of making use of DevOps is they try to release more products and features, right, within short time. That is the greatest advantage of making use of DevOps, right? And the basic advantages, right? Time taken to create and deliver software is reduced, obviously. Complexity of maintaining an application is reduced, and improved collaboration between developer and operation team. This is the primary thing, right? Collaborating with developers and operations. And continuous integration and delivery ensures faster time to market, because deployment is very, very important. As long as there is going to be continuous integration, continuous delivery, right? So that obviously gives you a faster delivery, and the market receives that particular product at the faster rate, right? So this is how the DevOps works with. And this is what the key takeaways when it comes to the discussion is concerned. Initially, we discussed about waterfall model. We have been talking about how Agile overtakes the waterfall model, and we discussed how DevOps overtake Agile model, and we discussed the 8 important phases of DevOps, and for each phases, what tools that has been supportive, all right? So that we discussed, and finally we discussed about the DevOps processes and advantages, right? To end up with, to have a link between your DevOps and cloud native. So basically, cloud native is a software approach of building, deploying, and managing modern applications in cloud environment, right? So I'm going to develop a software, some sort of development I'm going to do, and that I'm going to put it in the cloud environment, right? For this, okay, I have some 5 important applications, development of, if you like to develop a cloud native application, I need some 5 important aspects. In that 5 important infrastructure aspects, this DevOps is very, very important, right? Integration of development and operation, that is very, very important. And containers, right? There is a separate topic. I saw some 3rd day or 4th day, I'm not very sure. So that is important. And we already discussed about continuous integration and continuous delivery. When it comes to microservices, right? One service can be segregated into smaller components, so that it will be easy for development, easy for error correction, and easy for integration. So that is the purpose of microservices, right? So meaning when you like to even AWS, Amazon Web Services, right? Probably you might have heard about it. That uses DevOps in this particular cloud native application, right? When I browse, like there is a complete history about AWS that make use of DevOps tools, right, for the sort of cloud infrastructure, right? So all these things I have given already this and all we have discussed. So DevOps, and I told you about continuous integration, right? So as long as there is some sort of changes, you have to immediately rectify it and integrate it in case of any errors, identify, build again, and integrate it, and again go for deployment, right? When you do that, obviously the expectation is continuous delivery, right? So you create the product, and you as I told you, this DevOps gives you many number of products at a shorter time. So that is the advantage of this. And I told you microservices or small independent software components that collectively perform as complete cloud native software. So it is going to be small and specific problem. Obviously, it is a loosely coupled, right? It is going to be independent, because as long as it is dependent, that cannot be a microservice at all. So since it is independent, the focus is going to be on that particular microservice, right? That in turn will not affect other microservices, right? And finally, containers. So containers are very, very important factors, and they are the smallest compute unit in the cloud native application. They simply are the software component, right? Those software component I'm going to we are talking about some microservices, right? I'm going to pack every microservices and put inside a container, and in that particular cloud native system, that and all can be accommodated in this particular container, right? And at the end, as a final a thing, cloud native approaches has greater benefit, and in that efficiency, increase in efficiency, reduced cost, and it ensures availability also, because this is the greatest advantage. You do so many things, but if it is not available for the end users or the clients, that is of no use, right? So the purpose of cloud native application itself is availability, anytime, anywhere availability. That is the motto here, right? And to end up with, I acknowledge, as I told you, I learn from Simply Learn. So this is a software, a learning environment. I took so many contents from this particular environment, so I would like to acknowledge this Simply Learn for this particular content. So I end up this particular session. So I think I have given an introduction about the purpose of DevOps and how it has been used in cloud native applications, right? So with that, I end up, and I thank the organizers again for giving me an opportunity to be a part of this FDP and to deliver a lecture on this particular topic. So thank you for your patient listening, and thank you one and all.
Thank you so much, sir, for your enlightening and thought-provoking session today. Your valuable insights and deep knowledge on this topic have truly enriched our understanding. We are grateful for the time and effort you took to share your expertise with us, sir.
Yeah, thank you, Anandol, and I thank the coordinator Balaji, right, for conducting this in a greater way. Okay, thank you, Anandol.
I hope the session has sparked and provided meaningful takeaways for all of you. It was an excellent opportunity to learn from someone as esteemed as you, sir, and we look forward to applying these learnings in our respective fields. Before we conclude, I would like to open the floor for any questions or clarifications. If anyone has doubts, please free to raise your hands. Sir will be happy to address them.
மியூட் பண்ணிடலாம் சார் அப்போ மட்டும்.
Yes, in Azure platform also DevOps has been used. Azure, AWS, right, everywhere. No, as I told you, when it comes to research direction is concerned, right? Every, like, even the life cycle phases, even now, though we have a great time from starting from analysis, design, still there is a huge scope for testing. If you like to do research and testing, now there are so many, now I'm doing a research on quantum software testing, right? Now probably we are talking about cloud computing, right? Right now we have something called quantum computers. Quantum computers are much more advanced, so that now quantum computers are used for testing, right? So that itself is a research. So each phase has a great scope for doing research. Which public cloud platform most preferred? Now even this Amazon Web Services, right? So that has a great features. Now we are developing some learning environment. For that we are integrating with our AWS that suppose so many DevOps operations in that sort of things. Yes, right. So as I asked one like Saranya, okay. So meaning, if you say even waterfall model has been used in some industries, right? So waterfall model is not completely neglected at all. It is all about the conveniences, right, and features, right? If you're comfortable, even agile is the model that has been. Now DevOps has been upcoming, so probably people started using that when they experience some sort of fruitfulness in that particular thing. Probably they will adapt completely to that. In agile models, sprints can work parallelly. Not necessarily it can work one after another, because every individual sprint will be handled by individual teams. Not necessarily it can be done one after another. And one professor asked, throw light on how ML ops and DevOps relate. I'm not I don't have much on that sort of things. DevOps is a methodology or process. It's a process. It's a development process. How is security is ensured in DevOps? Whatever security terminology we use for a normal software development, everything can be applied for DevOps also. DevOps is not a sorry. When it comes to DevOps, it is a different perspective of software development. That's it. Okay.
Good evening, Professor.
Yes, sir.
Can you hear me?
Yes, Professor.
Yeah.
Tell me, sir.
It is a very nice session, and you have explained all the tools and other things in a most precious manner. I am expressing my sincere thanks to you. Thank you very much.
Thank you, Professor. Thank you very much.
Thank you.
So I thank you all for your patient listening. I know how things go with respect to online, but I see so many people being in online, and I can see messages also asking questions and meaning. I'm happy that you people have listened in online. So that is a great attempt, and I'm wholeheartedly thank you all. Right. I think the next speaker will be waiting, so I will end up right now. So we'll catch up later sometime today. So thank you, one and all. Thank you.
Thank you, sir.
Thank you, sir.
Yes, Balaji. Thank you.
Now I request Mrs. Nagamani Abhirami ma'am, Assistant Professor, to introduce our esteemed resource person, Dr. Sendil Kumar sir, for the next session.
It's an immense pleasure to welcome Dr. S. Sendil Kumar sir, Assistant Professor, University College of Engineering, BIT Campus, Tiruchirappalli, with over 2 decades of teaching experience. He holds a PhD in Information and Communication Engineering from Anna University and specialized in network security, cloud computing, machine learning, and wireless communications. He has guided many PhD scholars, published extensively many research papers, authored books, and been involved in research projects and patent filings. He has also held key administrative roles, including head of the department, and spoke for NPTEL SWAYAM. We are honored to have you with us today, sir. Kindly please take over the session, sir.
Thank you. I hope my voice is audible first.
Yes, sir, it's audible.
Okay. Thank you. Very good evening to one and all. First of all, I thank college management, principal, vice principal, coordinators, Balaji and Pavitra, so for giving opportunity as a resource person in this session. So excellent section given by Professor Shivakumar sir. Thank you very much, sir. Very interesting session. I enjoyed a lot from your session.
Thank you.
And then, so please share your PPT.
Sure, sir.
Pavitra ma'am, please share a PPT.
Sir, 1 second, sir.
Okay.
Vijay
Please put full screen. Shall I start? Ma'am.
Kindly unmute yourself, sir.
So, in this session, I am going to discuss about the introduction about the Dockers. So, Dockers, please put your first slide, ma'am. So, Dockers released in this platform released in 2013 by .cloud. It's a open source platform, a technology. This is not a software. Okay, this is you are going to build an image, a Docker image based on a different instructions. So it is developed for development, shipping, running the application by containerization. So containerization means build a package with dependencies. Dependencies means whether it is, suppose if you build the application with web-based application, you have to create, you have to use JavaScript, Node, web servlets. So these are you have to put into the Docker file, and then you have to build. Okay. So with all the libraries, resource files, everything you have to put into the Docker file is called customer containerization. Okay. So this is an open source platform. It has simplified the process of developing, shipping, and running application by using containerization. Okay, so you have to build a lightweight single unit with the help of all the Docker image. Okay, so the lightweight process means is a less number of source dynamically it will be adopted. So dynamically you have to allocate CPU usage, and then memory, storage, everything will be dynamically allocated. So comparing with virtual machines, it will be very less resources usage taken. So comparing with virtual machines, it will take less time to start up the process. Okay. So the initial goal was to simplify and streamline the deployment process, allowing developers to easily build, ship, and run application in different environments. That is a very thing. Portability is very, very important thing if you use Docker. Okay, so you have to container can run in many platforms like Ubuntu, Fedora, Linux, Unix, anything, any platform you can run easily without any issues. Okay. So as well as on the next slide, ma'am. Next slide, please. Why you are go? So why Docker became popular? So 4 important features, characteristics if you use Docker. First one is portability, and I told about that. Containers can run on any system that support Docker, making it easy to move application between environments. Suppose if you build a Docker container, you can run in any platform. Okay, you can run like Ubuntu, Fedora, Linux, Unix, any platform, there is no issue. Windows also. Okay, and then scalability means you can add multiple containers on multiple hosts. You can add a number of containers in the Docker hub, whether it is publicly or privately, in local machine. Okay, so no issue. So you can add n number of containers based on your request, based on the user request. Okay. So as well as you can add n number of multiple hosts also. So this is a second feature if you use Docker. Third one is efficiency. So containers share the host system kernel, making them more light. Already I told about lightweight. So dynamically you can allocate the resources like a CPU and then your memory, storage usage. Everything is dynamically allocated, so it will take less time comparing with the virtual machines, VM. Okay, and then isolation means containers are isolated from each other. That is, so many applications are there in your container. You don't know one interfacing the thing in between the applications. So containers are isolated from each other and the host system reducing conflicts. So no conflicts among the applications. So isolated environment you have to use if you take Docker. Okay. So and then architecture, ma'am, please. The third one. Go to next slide. And unable to move to next one. This is the architecture. So in the Docker architecture, only 4 important things are there. So one is Docker file. Another one is Docker image. Third one is Docker hub. Fourth one is Docker container. So Docker file is a sequence of instructions. For building a Docker image. For example, suppose if you use web application, you have to put Node, servlets, JavaScript, a Python application. You have to put all the commands, all the instructions in the Docker file. Okay, this is a basic thing. Based on the Docker file, you can build the Docker image. Okay, so in Docker image, you have to put the resources with less. Okay, so comparing with virtual machines, so Docker image is a more efficient than any other virtual machines. Third one is already you have created Docker image. Okay, you have to put into the Docker hub. Docker hub is a publicly that will be available in this cloud-based repository. You can put your Docker image into the Docker hub, and then you have to push from the Docker hub. You have to run in the Docker container. So these are the 4 important things. So the very good example, very good comparison among the Docker image and Docker container. The Docker real life example is Docker image is a recipe. Okay, so based on the recipe, you can prepare a dish. Okay, that is called a Docker container. Okay, so after this, my research college is going to give you in detail commands. The demo session is there. How to create the Docker file. Based on the Docker file, how to build the Docker image. In the Docker image, how to run how to access the pull or push. These commands will be taken by our scholar from the Docker hub. Already so many Docker images are available in the Docker hub. So in the after this session, so I think he is going to take 3 or 4 Docker images, Docker containers, and then finally is going to give entire commands, entire demo about Docker. So and then next one, next please. Next slide. So already I told about Docker file is a text file that contains a series of instructions to build a Docker image. And then in a Docker image is a lightweight process. Already told about lightweight because it has less number of resources dynamically allocated by Docker environment. And then standard old independent and executable package that includes everything needed to run a piece of software. The code dependencies, code, runtime libraries, environment variables, and configuration files are already you have to be built with a Docker image. Next one now. Docker hub. So already told. So what is the difference comparison between Docker file and Docker image? Already told. So it's like a set of oral instruction or a step-by-step guide on how to build a house. Okay, so oral instruction. Suppose if you want to build a house, so what initially you have to do means, so you have to give us oral instruction. So in this place kitchen, in this place the bedroom, this place is dining hall. So you have to give the oral instruction. After that, you have to prepare a blueprint. So blueprint is a Docker image. So Docker image is like a blueprint or a finished model of the house. So it represents the final product that you then use the modify and replicate once. So this one of and then
one more advantage if you use Docker, consistency is a very, very important thing. If suppose if you change any instruction in the Docker image, that will be reflected on the replicated images. So automatically consistency will be maintained. Otherwise, no use. Okay. Okay. Sorry. So, for example, suppose if you take an organization, so for 4 divisions are there. First one is design, and then software development, testing, and production. In all the divisions located in different places. Okay, so suppose if you use Docker container, they all use same version, same platform, everything. Okay, so conflict will be taken in between sectors. Okay, in the software organization. So that is the advantage. Okay, next one, ma'am. So Docker Hub is a cloud-based registry service provided by the Docker, where you can find, share, and store Docker images. So in this demo, in this live demo, so already so many existing Docker images are there in the Docker Hub, and is publicly available. So you can here Mongo and then Node, Python. These are the Docker images will be executed. Okay. So and then you have to use 2 commands. So push and pull. Push means push command is used for to pull the Docker image from the Docker Hub. Okay. To local machine. Okay. Or server. Push means you created a Docker image into Docker Hub. Okay, that is the 2 commands will be used in between Docker image and Docker Hub. Okay, next. So this is the Docker container. Already I told. Yeah, Docker container is a lightweight, portable, and executable package that contains everything needed to run a piece of software. So including the application code. Already I told about application code, runtime libraries, environment variables, and configuration files. So everything put into the Docker image, sorry, Docker container. You have to run with the Docker image. Okay, so containers are created from Docker images and run in the Docker engine, which provides the isolated environment for the application. Okay, so then next one is, so what are the so in the already told in the Docker architecture. So what are the basic commands? What are the basic commands in Docker file and then Docker image, Docker Hub from pull and push, and then how to run a Docker container. These things will be taken by our scholar. So if we suppose if you have any clarification how to run, how to execute the commands with respect to these 4 things, so you can ask me after this session. Okay, so now I hand over to Arun Prakash.
Hi, am I audible? Okay, yes. Ma'am, can you give me access to present?
Hi, ma'am. Is the screen visible? Yeah. So I would like to continue from where sir left off. Uh, Docker is to run Docker and build Docker-based application endpoints. We need to install its dependency and its application. One of the main dependency that we need is a Docker engine. What Docker engine? It's like it is a runtime that it takes builds the Docker image and containers from what we have into our computer. We can run Docker only in Linux-based system because Docker was built up to run on servers, and servers basically run on majority of Linux-based system. These are the supported platforms. I'm currently running Docker in yeah. I'm currently running Docker in Arch Linux. As you can see, it has support for Arch Linux. Fedora and Arch uses similar dependencies. You can run Docker in Windows, but you need a Windows subsystem for Linux environment. What it does, like runs the basic Windows environment, Linux-based environment in Windows. These are the installation for Docker engines. After Docker installing Docker engines, you need a Docker desktop. Docker desktop is a web GUI interface from which you can see like what are the containers you have, images. This is the Docker desktop. I can show you what Docker desktop looks like. This is the Docker desktop that I have installed in the Arch Linux distribution. As you can see, it has container, the images you run. After we run images, it will come here. These are the volumes and databases we require. The two main concepts in Docker, it's Docker images and Docker control. Two main very important concepts are the Docker images and Docker containers. You can consider images as the recipe on how to build a food. Like a recipe contains step-by-step instruction on how to construct a particular food, and it contains the technology we need, the runtime, what type of runtime we need to run on, like Flask or any Node.js application or any type of application, what runtime it needs, and that a different tech stack we need. Docker container is like when you run the image, the Docker engine will build the finished dish. The dish is like finished dish is like your container. It's a seculated environment inside your OS. What it does, like it builds a separate environment where you can run all the application that you have defined in your images. From what we gather from this is like Docker image is the instruction and Docker container is the dish built on based on the images. You can build any thousands of containers from the same image. Before I continue, I would like any questions that you have. You can raise hand if you have any question, or I would like to continue. Yeah. This is an example application I have built. This is a Docker file. A Docker file, you build the Docker file like code and Docker file. this builds a Docker file based. What in the you can do in the Docker file is like from this is a base image. What is a base image is like for this is a base image. These are the different base images available in the Docker. What is a base image is like you don't need to configure every type from the ground up. Like in the Docker app, there are different base images based on the environment you need. Like you go to Redis, Postgres, Python, Node.js, HTTP, Mongo for server-based NGIX. The basic images is like a basement of a building. It gives the base image from which we can build on our own separate application based on it. The base image I'm using here is Alpine. This is the working directory, the app directory app.py, where it says like what app.js is like, what the working directory I'm using, and the list when I run the Docker file, what file it should run it. This is the port I'm using, and this is the server, Express server. And this is the basic I'm displaying a Docker image and hello from Docker. I'm getting the image from the public folder, a Docker image. This is the local host from which I'm running the application. I have defined in the app.js file, and the Docker file get the working directory command host is that I should pull the app.js file from first. At the package.json file is like all the dependency I need to run my particular application, web application. This I'll name the name of my application, the main where my basic commands are there, what to run, how to run the application, the license and dependency. It will the Docker file I have automatically copy the package.json, and the run command will install all the dependency. And the expose command will expose the port in which I will run the application. After exposing, it will automatically run npm start to run the application. If you have multiple applications like a database, a web server, backend, it would be not recommend to run all the application in the single container, because it will make the container very big. It is and harder to debug. It is generally advised to run multiple containers for your required file. The main need for Docker is like when you build an application, you build for your system, optimize for your system. And if you want to like run in the thousands of systems in the world, they have all different dependencies. Docker standardized this. You have, I think someone have faced the issue where the code runs perfectly on your system. Even if you copy all the system and required files in another system, it breaks. Docker avoids it. Docker runs the application layer by layer. Like it will first run the from command, then the work directory, then the copy, then run. What is the layer and layer command application? It's like it caches all the commands. If you change a particular application or a particular line in code, it will no need to run from the startup. It will automatically use the file that are in its caches and makes a build extremely fast. Like I was explained, the run npm install happens when you're building the application. This is the expose port that the computer exposes, and this is the port that the container exposes. What is like I'm telling the computer port to talk with my computer port based on this 5000. Like I said, a chain container of everything doesn't make sense. Multiple containers for different applications, different type of services is the way to go. You may have doubt like if I'm running multiple containers, how will I run in the same code? For that, we use a docker.yaml file. Docker.yaml file is like this is it will you need to you will configure multiple containers in the same file. This is like the container I'm showed in the Docker file, and this is another container, a database container. This is a database container, and this is another web application container based on the Python web. This is the Docker file for the Python web. For the Node.js application, I had like npm install. For the Python Docker file, I am using a different image, Python image, working directory, and I am telling to copy the requirement.txt and run this command to install all the requirement of all the commands in the Flask requirement test Flask file, and using a different code for the Python application. This is the, as I mentioned, this is the different containers in the YAML file. The services, web services, another web service I'm running, and a database.
What about the YAML file? Okay.
Yeah, I would now like to build and show you how to build the container. Any doubts till now, you can raise a hand.
If you have any doubt, please raise your hand, please. Otherwise, move to next. Okay.
This is the Docker compose of what is it is building the Docker file. All the required, it will automatically install all the required dependency and expose the codes. It's pulling the database image from the Docker hub. Okay. You see, it's like Python web internet. It's identifying the Python file, transferring the Python file to the Docker file, and it's like pulling all the required files. It is caching the dependencies, exporting the images. See, this is a Docker file web create Python web application, and serving the Flask hub. This is the database it automatically generated. I can show you in the Docker desktop. See, these are the containers that we have created now. Docker.compose is the container that we have created. It automatically shows what is the container memory usage, CPU usage, and the images that we built. MongoDB image, Docker Compose image for Python, and a Docker Compose image for the Node.js application. Volumes is like the data storage for your Docker containers. It's a database is like any input I give, it will store in the Node.js MongoDB database.
டைப் பண்ணுறேன்.
This is the Python web application that we have built. As you can see, I just run the Docker compose app file command, and it automatically built the images, and now it automatically build the required install the required dependencies and ran the application. This is the Python web application that I have showed, and this is the Node.js application that we have run. As you can see, I have run two different images. This is a Node.js application and a Python application in the same environment. This is what Docker helps. It helps like run to multiple applications, same environment without harming or disturbing our existing environments. The YAML file automatically build the different images. Automatically 3 different images, a Python image, a Node.js image, and a database image that we have defined here. This is the multiple container that I have been talking about. As I said, you can one of the drawbacks of the Docker is like because containers are isolated, they can't share data between each other. So what we have done is like defined volumes for it. The volumes are shared between all the containers so that it can automatically share data. As you have seen, I will run to shut down the Docker building. You can press either Control C based on your environment, or you can run the command Docker compose down. It will automatically shut down all the working environments. It has removed all the working environments. You can verify it from here. As you can see, all the images have stopped running, but it stays in cache in case you need to run again. I can show you. As you have seen, all the containers have stopped, and the application is unable to connect. If I run again Docker Compose up, let's see, all the containers have started. The containers are shown to be running, and the application runs again. This is what Docker helps.
Hello? Net connection நல்லா ஸ்ட்ராங்கா இருக்கணும். எல்லாமே ஒரே இதுல நடக்குது. ஓகேவா? Hello?
I've stopped all the containers.
Screenshot எடுத்து அனுப்புறீங்களா மேம்?
This is the different. You can Docker Compose log is a command. You can see any errors that are occurred. Is the dependency run right? What port is it running on? As you have seen, the Python application is running on this port, and the web application is running on another localhost port. You can also run PS to check the what type of images, you have name of the image and this command in this service to run the Docker PS image. Yeah, this is a Docker Scout. What Docker Scout is like, it defines how to, if you need to look, if log doesn't help, and if you want to like look more thoroughly in the image, you can use Docker Scout and look any vulnerabilities that are in your Docker images. As you can see, it shows the vulnerabilities in our system. And you can see that my container is using RAM 1.1 GB, CPU 13%. This is what Docker Desktop helps.
Like it,
And this is the resources I can dynamically accord. Docker engine is like what is the build is happened. Using Kubernetes, we can also run multiple Docker filing cloud. This is what Docker helps. You can also push the images what you have created in the Docker Hub, and if you all you need to share is like the Docker file and the Docker YAML file using the same Docker Composer command. In any computer in the world, you can run the system. Yeah. Yeah, as you have seen,
in Docker file, what are the commands are available? In Docker image, what are the commands? And the Docker,
these are the Docker images.
Yes, what are the commands?
These are the Docker image that, as I have shown. To conclude, I would like to recap. This is the Docker images, image file. This is the different containers that are running. Container. This is the images, MongoDB image, Node.js image, and a Python image. The Python image that I have defined here, the Node.js image I have defined here, and the database image. And this is the volume, the database data that I have shown that are shared between the containers.
Possible in any other images from Docker Hub.
As I have shown, this is a pre-built images that I have taken and configured based on my needs. Yeah. Based on your requirement, you can take any different images.
What are the images are available in the Docker Hub?
Yeah, these are the images that are available in the Docker. Ubuntu operating system, Redis. I have basically used the Python and
so what are the Docker images you have completed in this from these images?
From the Python image, I have configured this Docker file.
Yes.
And from the Node.js, I configured this Docker image file. If I'm running Docker Compose up, I have built a multi-container application, a web application, and a Python web application, and a database. Yeah. So, any doubts?
Dear participants, if you have any clarification doubts respect to how to give the command, commands for execution, anything you got to ask. Pavitra, please. Any questions?
Thank you very much, sir, for your enlightening and insightful session. Before we conclude, if any participants have any questions or doubts, you may kindly raise your hand and clarify them with sir. We encourage you to make the most of this opportunity to interact and gain further insights.
So yeah, how to execute, how to give the command for build or run, create the Docker file, anything. Can ask that. So my final word is, if you need fast, efficient, isolated environments, of a small task, Docker is very powerful platform. Okay. So those who are having, those who are working with the cloud environment, okay. So Docker is a very powerful tool. So the comparison among the Docker and the virtual machine is, okay. So Docker is a platform runs on operating system layer virtualization. But in virtual machines are run on hardware virtualization. So comparing virtual machine, Docker is more speed. Okay. So startup time is very less comparing with virtual machine. It will take in seconds. Okay. But if you start up the application with virtual machine, will take minutes. Okay. So it will take more. It will take more time. Okay, based on where it runs on hardware layer of virtualization. So this is the advantage if you use Docker. Okay. So any other clarification with respect to Docker? Ma'am, sorry, ma'am.
Ishwarya Manu, ma'am. The question is like how to choose good, effective Docker images. It depends on based on your requirement. Like I'm building a Node.js application here, the app.js file. So I'm taking a pre-built the basement of a Node.js application, and I'm running the building my image Docker image based on it. But similarly, because for another image I'm using a Python application. So what I'm doing is like taking the Python image from here basement and building the Docker image based on it. For a database, I'm using a MongoDB database. So what I would do is like I know that I'm using a MongoDB software. So Postgres is a similar database software, but I know that I want to use MongoDB. So what I will do is like go to Docker and search for a MongoDB image. This is the MongoDB image that is in the Docker. I think does it solve Ishwara Manama? Your doubt? Yes, can you give it one second? Yes. Another question is from Saranya ma'am. How Docker differs from VM? I would like to show this with an example. Yeah, I think, yeah. What VM does is like what VM does is like it builds on the hardware and using a hyper application like hypervisor. it what it does like it manages multiple virtual machines. Before the Docker, we were using this type of software. The hypervisor and the host hardware. What it does is like if you take like I have a 16 GB RAM and 1 TB storage. My hypervisor, or you can manually do it using any of the VM application like Oracle VM. This is a VM VirtualBox configuration. What you can do is like assign like for Ubuntu distribution, I want 2 GB RAM and 300 GB storage. And for another Windows, I would like a different virtual machine for different. What it does like separates your hardware requirements into multiple virtual machines. This leads to systems slowing down because now you are separating your 16 GB RAM into 2 GB RAM. It's like using a downgrading from a iPhone 2 and like iPhone Pro Max to a button phone. You are downgrading your the system generally runs slower because you need to install the kernel again. Kernel is like the base configuration of any computer program. It's a base program. We have the OS and kernel and the hardware. OS and kernel talks to the hardware. Each OS run a multiple kernel and talks to the hardware through the hypervisor. What Docker does is like I think this will be much better. What Docker does is like you can have any OS installed in your system. It will like what the amazing thing Docker does is like it will containerize your OS, not the hardware. As you have said, VM containerize the hardware, separate the hardware, but the Docker will use all 16 GB of your RAM and it will build based on the images. It will build on your base OS. Any base OS, you can have Ubuntu, Windows, any base OS, and it will run based on the Docker with separate containers like VM on top of the OS. Because of this, it uses all the 16 GB RAM available and leading to a fast and efficient workload. Does it answer, Saranyam? Can you reply? Saranya ma'am, does it answer your question?
When you use Compose,
yes. Thank you. Compose to use like multiple container when you have to run multiple container. Like as I have shown here, I use Compose. If you have single Docker file, I no need to write Compose. If you have multiple container application, I need to run 2 different websites, and I need to also have a database. It automatically share data between the multiple containers. It will automatically share data between the multiple containers and it will efficiently manage the multiple containers. Any further questions? Yeah, Imran Jalil, sir. Yeah. First, I would like to. Yeah, Dr. DK, you have raised your hand. Can you ask your question? First, I will like to answer the Imran Jalil, sir. Yeah, you can research area in Docker and Kubernetes is like the CI/CD pipelines. What CI/CD pipelines is like automation of the deployment in the cloud. Let's say you have built your application in your local machine. You need to deploy in the cloud. How do you, if you have like 10 users now, 10 user. If your application becomes viral and 100 people start using 1,000, 10,000, 1 lakh, what you can do that is like you deploy it using Kubernetes. Kubernetes is an extension of a Docker. What it does is like, as you have seen in the Docker directory, it has a Kubernetes. What it does is like Kubernetes will automatically scale your application. It will generate what is like called pods. Yeah, Kubernetes pod. What it is does like it runs a cluster. Each of the plot when if you have 10 application, it will have a single pod. If you have 100 application, it will automatically generate 10 more pods. It will automatically scale you in the cloud. For research area, you can see deployment, how you can efficient run Docker images and how to manage different Kubernetes applications in cloud. For Imran sir, I would like to try you Puducherry. Puducherry is like Kubernetes and Cloud Native Manager. You can visualize what happens in your Kubernetes application. Does it answer your question, Imran sir? Can you reply? Yeah. I would like to answer next Sai Kumar sir. As you have asked, Docker Compose and Docker Swarm. Docker Compose is to like build the multiple container application and to deploy it. What Docker Swarm does is like it manages the Kubernetes cluster of multiple Docker hosts. Like I'm running a backend from my Docker host. Another computer is running another website service host. I'm running backend. The Docker Swarm is like it manages the multiple pod in the Kubernetes cluster. These are generally different use cases. Does it answer your question, Sai? Sai. Yes, yes, sir. Thank you. Saranya ma'am asked, how do you ensure security in Docker? Docker is like open source. What open source is mean? Like you can inspect the code and find the vulnerabilities because all the source code is already in the internet. You can see like what are if anyone has any malware, any bug that they have implemented. Also, it uses SHA-256 for encryption and decryption in the Docker service. While running, it uses authentication SHA-256 and for encryption and decryption. And another thing is like if you want to, this is what Docker provides. If you make some mistake in your Docker image that you're building, you can use Docker Scout tool. The Docker Scout tool. What it does, like it analyzes any vulnerabilities that you have in your images. It will when you run Docker Scout, it will show what vulnerabilities that you have in your image, the image you have built. Like if you are in my application code, if I have any vulnerability or the security is not that, Docker Scout will automatically parse to the application and detect any vulnerabilities that you have and rate based on scale of. Does it answer your question, Saranya ma'am? Yeah, common use cases of Docker are like, that's why I've been talking about, like, if I need to run this web application, this is my Node.js web application code. This is another Python application code. Node.js need these dependencies. My Python application need this dependencies, and my MongoDB need other dependencies. MongoDB, I need to install MongoDB. Generally, it takes a lot of time to install and deploy different applications on the same computer. Even if you deploy, it is you cannot say like if it works on your computer, it will work in the server or it will work in another computer. What Docker does is like take the recipe example. If I give like a particular recipe, like chili powder 10 gram, salt 5 gram, and you need to stir only 5 times only to get the dish. If I specify this recipe, even if I hand out the recipe to another machine, it will based on the recipe, it will generate the same application, same environment. So Docker does it like it will make 100% sure if you have the recipe, it will also run in your machine. Doesn't matter what type of Windows or operating system you have. Does it answer your question, Saranya ma'am? You need to log into Docker Hub. You need to log into Docker Hub. It is similar to GitHub, and you can from this repository you can go to your terminal and write Docker push and the image name. If you have signing into your terminal, it will automatically generate a repository and it will push the images. Does it answer, sir? Yeah, Ishwarya, ma'am. Does it answer? Anita Tambi, ma'am, can you message what query you have? I would like to answer Ajay Angadi's question. Whether Docker supports cloud native app deployment. Yeah, Docker is what it does, like based on the different server you have, it will automatically backend for the cloud native application. It will build your application, it will deploy it, and if I use from another computer, I just need to run my Docker image file and it will automatically deploy from the server or the Docker hub based on your image. Ajay sir, does this answer your question? Yeah, Ajay sir, yes. Thank you. Anita, ma'am, into Docker ensure application consistency. As I've said, this is the Docker file. This is the recipe. I just need to share the Docker file. Doesn't matter from GitHub or any Docker Hub, any repository. You can simply copy paste this file and run the Docker. Docker up command. Docker compose up command. It will based on the recipe, because the recipe is same. Doesn't matter any system, any environment, any operating system. Because the recipe is same, it will automatically on running Docker command doesn't matter. If I run the same command using the same file, it will automatically pull the base image from the Docker app and it will build the same system. That's the advantage of Docker. VM doesn't give this. Does it answer, Saranjana? Any further question? Any further question? Anita Tamim, I think can ask your question in the comments. You have raised your hand.
Ma'am, any other questions, ma'am, regarding command? Any other?
Yes, ma'am. I think data, if you need to replicate your machine, like if I want the same application, Python or web application in another computer, or if the deploying server and cloud server and someone wants to like access the same web page, same login, like if you have a Facebook page, if you open the same page in your mobile or your computer, it stays the same. Docker gives consistency. Yes, ma'am.
Okay, participants, any other questions with respect to comments? Otherwise, I conclude the session, please. Okay, so I conclude the session. Once again, I thank you all the organizers, Balaji sir, Pavitra ma'am, principal, vice principal, all the. So I hope all the participants enjoy. Oh, one more question from Saranya CSC. How do you create Docker network? Yes. Yes, ma'am.
Yeah. Docker doesn't, as you have said, Docker is like you need to using an extension with Kubernetes. Kubernetes manages different Docker file if you want to create a network, Docker network. Like I have said, it created different pods based on the requirement. It automatically scales your data. That's why it will help you. Sir, does it answer, Saranya? Pavitra ma'am, I think I've already said ensuring security. Docker uses different security protocol. You can also use SHA-256. By default, it uses SHA-256 for building images, for encryption and decryption. Because the Docker project is open source, you can go to GitHub and check the source code yourself for vulnerabilities. Or you can use Docker Scout. What it does is like it goes to all the applications code and scan any vulnerability that you have. I think this answers your question, Pavitra ma'am.
Any other questions?
Dear participants, any other questions?
So once again, I thank organizers for giving opportunity as a resource person in this technology doctors. So I thank organizers.
Thank you, Professor Sendil Kumar sir.
Thank you. Suppose if you have any doubt, any clarification with respect to this doctor, fundamental comments, feel free to ask me. Still, for 10 minutes are there, no problem. Please, how to execute, how to. Thank you very much. Thank you. So, Balaji,
Yes, sir. Ma'am, Pavitra ma'am.
So to conclude, I think this solves everything from Docker and its application, and we also seen extension.
Thank you, sir. We truly appreciate your time and effort in sharing your wisdom with us today. So, dear participants, we have an important update for you. The feedback link will be shared in the WhatsApp group as well as via email. Now it's shared in the chat box also. We kindly request you to fill out the form, which will be remain open until tomorrow 10 a.m. Before that, kindly submit your Google Forms for marking your attendance. If you haven't joined the WhatsApp group yet, don't worry. A link has been already shared with you via email. Please join the group for further updates and to get answers to any queries you may have in the upcoming days also. We hope today's session was insightful and that you have all gained valuable knowledge. Let's keep up the energy and enthusiasm for the next 6 days, upcoming days also. Looking forward to see you all tomorrow. Kindly, kindly please, everyone come to camera. We'll take one photo, group photo. Kindly open your camera, turn on your camera, please. I request everyone to turn on your camera. I request all the participants to turn on your camera, please.
Madam, please activate the camera. Host deactivated the camera. It's showing, ma'am.
1 minute, so we'll check.
Camera is deactivated. Hello.
Check now, ma'am.
Fine, now working now.
Yeah. Thank you. Thank you. Thank you.
Thank you for the session, ma'am.
எனக்கு வந்து அதுக்கு ஒரு 10 பேர் மட்டும் தான் ஃபோனில் தான் ஸ்லைட் பண்ணி பார்க்க முடியும் சார். மொபைலில் நான் ஸ்லைட் பண்ணி பார்க்கலாம். இல்லை சார், ரெக்கார்ட் ஆகிறதுலையும் இது மட்டும் தான் சார் ஆகும். நம்ம ஸ்க்ரீன்ஷாட் தான் எடுத்துக்கணும். இப்போ தெரிஞ்ச பாருங்கள், மொபைலில் பார்க்குறப்போ நான் நல்லா ஸ்க்ரோல் பண்ணி பார்த்துருக்கேன்.
I hope for everyone the camera access has been given. Yeah, thank you. And if anyone interested to give feedback about today's session, you can. You can volunteerize.
Myself is Santosh Kumar. I'm from Anil Neerkonda Institute of Technology, Visakhapatnam.
Yes, sir.
And today's session was, I thought it was going to be a bit lengthy, but when we dig into the concept, the time was not at all an issue, because the topics that were being covered are very informative, and I appreciate the effort that the entire team is coping up until this time, and I appreciate it a lot. Thanks for the session, ma'am.
Thank you so much, sir. Any other participants? Any other?
Good evening. Can you hear me?
Yeah. Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. This is a wonderful session, Professor Dr. S. Kumar, sir. You have given a very deep insight related to the Docker session. Thank you very much for your timely teaching. Thank you.
Thank you. Thank you. Thank you.
Welcome, sir.
Thank you, Professor Kumar. I thank all the participants.
Excuse me, sir.
Yes, sir.
And the participant has to give feedback.
Pavitra ma'am and Senthil sir, when do we have this recording sessions link, the sessions recording link?
Pavitra ma'am,
Sir?
when you get it recorded?
Yes, sir. Regarding public WhatsApp groups.
Sure. That would be great, helpful to review the entire session once again before coming back to the new session.
Yes, sure.
Thank you, ma'am. Thank you, sir.
Okay, we'll do it. Shivashankari, ma'am.
Yes, ma'am. Good evening, everyone. So, first and foremost, I would like to extend my sincere thanks to Sri Venkateshwaraa College of Engineering and Technology for organizing the insightful webinar and giving us the opportunity to engage in an interesting topic. And the organizers and speakers have truly set a high standard by creating and fostering learning. And it is also a privilege to be a part of such event. And I appreciate the effort that I've been making for this webinar successful, right from the agenda to execution. So once again, thanks for the wonderful opportunity given by the college. So wishing you all continued success. Thank you.
Thank you so much, ma'am.
Okay, sir.
Once
Thank you to all the participants. Tomorrow we'll meet. We will share the tomorrow's schedule and resource person details and what are the topics to be covered by tomorrow. We have to send it through your mail and WhatsApp group. Okay. Thank you once again. Thanks to all the participants and resource person. Thank you, sir.
Thank you. Thank you, Kalash.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
ஃபார்ம் வாட்ஸ்அப்பில் போட்டிருக்கோம் இங்கே போடுறோம் நாங்கள் போட்டிருக்கோமா? ரெக்கார்டிங் ஸ்டாப் பண்ணுறா சார்? ரெக்கார்டிங் ஸ்டாப் பண்ணுறா? ஹலோ, என்னது மேம்? நான் தான் மேம் என் பண்ணேன். இல்லை என் பண்ணிட்டேன் மேம். கார் தான் என் பண்ணேன். யார் மேம்? செந்தில்குமாருக்கு ஒரு 2000 ஃபைன் போட்டு எத்தனை நாள் சொல்லுவாங்க? okay, ma'am.